Assalamu alaikum. In this video I will continue the explanation of Chapter 7 Polynomials Part 2. The objectives of this lesson are: characterize a root of a polynomial, characterize the division of a polynomial by x minus a, methods of division of a polynomial by x minus a using identical polynomials and the classical division. Factorize a polynomial. Please prepare the following materials: textbook, pens, draft papers, copybook, and calculator. Dear students, you must have a previous knowledge about the following topics: how to use the following remarkable identities, how to factorize a polynomial using common factor, remarkable identities, and completing the square. Root of a polynomial. Definition. Consider the polynomial P of X. The real number alpha is called root or 0 of P of X if and only if P of alpha equal to 0. Example, given the following polynomial P of X equal x squared minus 5x plus 6. Part 1, prove that 3 is a root of P of X. Part 2, is 4 a root of P of X? Justify. Solution. Part 1, P of 3 equal 9 minus 15 plus 6, which is equal to 0. Then 3 is a root of P of X. While in part 2, P of 4 equals 16 minus 20 plus 6, which is equal to 2, does not equal to 0. Then 4 is not a root of P of X. Characterize the division of a polynomial by x minus a. Property. When a polynomial P of X of degree n is divided by x minus a, then the quotient is a polynomial denoted by Q of X, and the remainder is a real number denoted by R, such that P of X equal parentheses x minus a multiplied by Q of X plus R, and the degree of Q of X is equal to the degree of P of X minus degree of x minus a, which is equal to n minus 1. Example, consider the polynomial P of X equal 2x cubed minus 9x squared plus 13x plus 8. Part 1, verify that P of X equal parentheses x minus 2 into 2x squared minus 5x plus 3 plus 14. Part 2, determine the quotient and the remainder of the division of P of X by x minus 2. Solution. P of X equal parentheses x minus 2 into 2x squared minus 5x plus 3. Let's multiply x minus 2 into 2x squared minus 5x plus 3. X multiplied by 2x squared is equal to 2x cubed. X times minus 5x equal minus 5x squared. X multiplied by 3 is equal to 3x. Minus 2 multiplied by 2x squared is equal to minus 4x squared. Minus 2 times minus 5x is equal to plus 10x. Minus 2 times plus 3 is equal to minus 6, and we have plus 14. It is equal to 2x cubed minus 9x squared plus 13x plus 8. Part 2, P of X is equal to parentheses x minus 2 into 2x squared minus 5x plus 3 plus 14. Then the quotient of the division of P of X by x minus 2 is 2x squared minus 5x plus 3, and the remainder is 14. Remark: when the remainder of division of the polynomial p of x by x minus a is 0, we say that p of x is divisible by x minus a, or x minus a is a factor of p of x. We say that p of x equal x minus a multiplied by q of x. Example: consider the polynomial p of x equal 2x cubed minus 9x squared plus 13x minus 6. Part 1. Verify that p of x equal parentheses x minus 2 into 2x squared minus 5x plus 3. Determine the quotient and the remainder of the division of p of x by x minus 2. Part 3. Deduce that p of x is divisible by x minus 2. Solution: let's multiply parentheses x minus 2 by 2x squared minus 5x plus 3. X multiplied by 2x squared equal 2x cubed. X times minus 5x equal minus 5x squared. X times 3 equal plus 3x. Minus 2 times 2x squared equal minus 4x squared. Minus 2 times minus 5x equal plus 10x. Minus 2 times plus 3 equal minus 6, which is equal to 2x cubed minus 9x squared plus 13x minus 6, which is equal to p of x. Part 2. P of x equal parentheses x minus 2 into 2x squared minus 5x plus 3. Then the quotient of the division of p of x by x minus 2 is 2x squared minus 5x plus 3, and the remainder is 0. Part 3. Since the remainder is equal to 0, then p of x is divisible by x minus 2, or we say that x minus 2 is a factor of p of x. Property: x minus a is a factor of p of x, or p of x is divisible by x minus a, if and only if a is a root of p of x. Recall that a is a root of p of x if and only if p of a equal to 0. Example: consider the polynomial p of x equal 2x cubed minus 5x plus 3. Prove that x minus 1 is a factor of p of x. Solution: since p of 1 equal 2 into 1 cubed minus 5 into 1 plus 3 equal to 0, so x minus 1 is a factor of p of x. Methods of division of a polynomial p of x by x minus a. First, we will use identical polynomials. Example: divide p of x equal x cubed minus 11x squared plus 6 by x minus 3. Solution: you know that p of x equal parentheses x minus 3 multiplied by q of x plus r for all real numbers x, and you know that degree of q of x equal degree of p of x minus degree of x minus 3. And we have here degree of p of x equal 3 minus degree of x minus 3, which is equal to 1. So degree of q of x equal 3 minus 1 equal 2. We denote that q of x equal ax squared plus bx plus c, where a, b, and c are 3 real numbers. Hence, x cubed minus 11x squared plus 6 equal parentheses x minus 3 multiplied by ax squared plus bx plus c plus r. So x cubed minus 11x squared plus 6 equal x times ax squared equal ax cubed plus x times bx equal bx squared plus x times c equal cx minus 3 times ax squared equal minus 3ax squared minus 3 times bx equal minus 3bx minus 3 times c equal minus 3c plus r. So x cubed minus 11x squared plus 0x plus c equal ax cubed plus b minus 3a into x squared, because the common factor between bx squared and minus 3ax squared is x squared, plus c minus 3b multiplied by x plus r minus 3c. Then by comparison, 1 equal to a and b minus 3a equal minus 11 and c minus 3b equal 0 and r minus 3c equal 6. So a equal to 1, b equal minus 8, c equal minus 24 and r equal minus 66. Then p of x can be written as parentheses x minus 3 into 1x squared minus 8x minus 24 minus 66. Now we will use classical division. Example, divide p of x equal x cubed minus 11x squared plus 6 by x minus 3. Solution. Step 1. Divide 1x cubed by x. You get x squared. Then multiply x squared by x minus 3 and put the answer under 1x cubed minus 11x squared plus 6. X squared times x equal x cubed. X squared minus 3 equal minus 3x squared. Then subtract 1x cubed minus 11x squared plus 6 and x cubed minus 3x squared. 1x cubed minus x cubed equal 0. Minus 11x squared plus 3x squared minus 8x squared. You must pay attention that the sign minus is changed to plus, because minus times minus equal plus. And here we have plus 6 minus 0 equal plus 6. Step 2. Divide minus 8x squared by x. You get minus 8x. Then multiply minus 8x by x minus 3 and put the product as shown. Minus 8x times x equal minus 8x squared. Minus 8x times minus 3 equal plus 24x. Then subtract minus 8x squared plus 8x squared equals 0. Here we have 0 minus 24x equal minus 24x plus 6. Step 3. Divide minus 24x by x. You get minus 24. Then multiply minus 24 by x minus 3 and put the product as shown. Minus 24x plus 72. Then subtract minus 24x plus 24x equals 0 plus 6 minus 72 equal minus 66. Now if we want to divide minus 66 by x, we cannot, so we will stop the division. Factorization of a polynomial. Definition: factorization is the transformation of a sum into a product. To perform factorization, we use one of the following. A common factor. It is explained in Chapter 2. B remarkable identity. Also it is explained in Chapter 2. C root of a polynomial. Using root of a polynomial. Let P of X be a polynomial and A be a given real number. We know that if A is a root of P of X, P of A equal to 0, then X minus A is a factor of P of X. This property may be used to factorize the polynomial P of X and also to solve the equation P of X equal to 0. Example, factorize P of X equal x cubed minus x squared minus 4x plus 4. Solution: if A is a root of P of X, then A must be a divisor of 4. The possible values of A are plus or minus 1, plus or minus 2, plus or minus 4. You must test plus or minus 1, plus or minus 2, plus or minus 4 to get the root of P of X. Upon testing, we get P of minus 1 equal minus 1 minus 1 plus 4 equal to 6. Does not equal to 0. So minus 1 is not a root of P of X. P of plus 1 equal 1 minus 1 minus 4 plus 4 equal to 0. So plus 1 is a root of P of X. Hence x minus 1 is a factor of P of X. Now we will divide x cubed minus x squared minus 4x plus 4 by x minus 1 using a classical division. X cubed divided by x equal x squared. Now we will multiply x squared by x minus 1. We get x cubed minus x squared. Then we will subtract. We get minus 4x plus 4. Now minus 4x divided by x equal to minus 4. Then we will multiply minus 4 by x minus 1. We get minus 4x plus 4. Then we will subtract. We get 0. So the quotient is q of x equal x squared minus 4, and the remainder is r, which is equal to 0. Then P of X equal x minus 1 into x squared minus 4. So we can write P of X equal x minus 1 into x minus 2 into x plus 2.